So if you have seen the previous video, by now you must be knowing that what is feed-forward artificial neural network. And in this video, we will be learning that what is forward propagation, where do we use it, and how does it work, and what are the different steps involved in its working. So without wasting any time, let's get started. So what is forward propagation? So forward means to move ahead, and propagation is a term related to spreading. So in forward propagation, we feed input to our neural network, and the input gets spread to the hidden neurons and the output neurons, and the input moves ahead in the forward direction, and we get output from the other side. So we feed input, it gets spreaded to the further layers of the neural network, and after that we get an output from a neural network. So that is known as forward propagation. And where do we use it? So we generally use the concept of forward propagation in almost every neural network. So every neural network that you will be encountering in the future will be using the concept of forward propagation. Whether you will be learning any complex neural network or you will be starting with any simple neural network, forward propagation is a step that is involved everywhere. And what are the different steps during forward propagation? So at every neuron, there are two steps involved. The first is known as preactivation and the second one is known as activation. So during the preactivation, what we do is we feed our input to our neuron. The inputs get multiplied to their respective weights. And once this step has been done, once the multiplication has been done, a bias term gets added to the product. So this whole thing happens during preactivation. And during the second step of activation, what we do is we feed the value that we got during the step 1 into activation function. So this is step 2. So in step 1, we multiply our inputs to the respective weights and add a bias term. And in step 2, we pass the input that we got from the step 1 into an activation function. Now let us try to understand in detail the working of a neuron, the working of forward propagation inside a neuron. And remember, each of these steps of preactivation and activation happens inside a single neuron. And remember, these steps of preactivation and activation happens inside one single neuron. So for every neuron, the same steps take place. For example, here this is my neuron. And suppose this is my neuron. I feed input x1, x2 and x3. They get multiplied. This is happening inside the step 1. So they get multiplied with their respective weights. X1 gets multiplied to W1, X2 gets multiplied to W2, and X3 gets multiplied to W3. So here you can see that W1 is multiplied to X1, W2 multiplied by X2, and W3 multiplied by X3. So this happens here during the first half of a neuron. So you can see that if I simplify it and add a bias term here, the whole equation looks like that of a linear regression. Now I pass this equation, I pass the value that I obtained here inside a activation function, and this happens during the step number 2. So I multiply the inputs to respective weights, add a bias term, and now this whole value that we got gets passed to our activation function during the step 2. Now you must be wondering that why do we add a bias term? What is the use of adding a bias term? So if there are multiple reasons for it. So suppose I don't add bias and my initial weights are set to 0. So what will happen is that the input that my activation function will get is 0 because my weights are 0. So whatever the input might be, whatever the x1, x2 might be, the whole answer is going to be 0. And hence my whole neuron will be useless. And during the training, I won't be able to leverage or I won't be able to use the neuron effectively because from the output of the activation function, I will be basically getting 0. So I add a bias term so that I don't get a 0. And the second reason is that you saw that during the step 1, I get an equation of a linear regression. So suppose this is a line of my linear regression, y is equal to mx. So if I change the weights, the steepness of my line will change. If my line might look like this or this or this. But if I want to shift my line, I have to add a constant. I have to add an intercept. I have to add another term, a constant term. So I am adding here a bias term so that if my line is this, it gets shifted. So whenever I want to shift the line, I want to add a bias term. So there are two reasons of adding bias. The first one is that I don't get output as zero from a neuron, and the second one is that I can shift the line during the pre-activation step. Now let us try to solve a question so that you will get a feel of forward propagation. Suppose I am feeding this data set where x1 is 4, x2 is 5, x3 is 6, and my output is 1. Here my output is my target variable. It is the output that should actually come from my given data set. It is the true value. It is my target value. And my weights, let us assume that my initial weights are, I am setting my weights to be 0 0.1, 0 0.2, 0 0.3 and 0 0.4. And my bias is 0 0.1 and 0 0.2. Now I have to find the output from my whole neuron. And this is what my neural network looks like. So here you can see that this is my first neuron and this is my second neuron. Inside the first neuron, you can call this neuron as hidden layer 1 because it is inside, it is a hidden layer, and you can call this as the output node. Inside the hidden layer, during the forward propagation, there will be two steps. The first one is going to be preactivation and the second one is going to be activation. So during the first step, what I do is I will multiply these inputs x1, x2, x3 with their respective weights. And after that, I will add a bias term. So I will multiply my input, which is my 4, 5 and 6 with their respective weights, that which is 0 0.1, 0 0.2 and 0 0.3. Here you can see that my inputs are 4, 5, 6 and my weights are respective weights are 0 0.1, 0 0.2, 0 0.3 and 0 0.4. So I will multiply these things and I will add my bias term 0 0.1. Here you can see that during the first hidden neuron, the hidden layer, I am adding a bias term b1 and the value of b1 is 0 0.1. So after I solve the equation, I will get the value of y as 3.3. So this is my step 1. Now in step 2, what I do is I will pass the value of y, I will pass the value of my pre-activation step inside an activation function. For example, I am using an activation called sigmoid function. Remember, there are multiple activation functions present. There is sigmoid, there is tanh, there is relu, there is leaky relu, there is p-relu, there are so many activation functions. But for this case, for the sake of simplicity, I will be using sigmoid function. So I will pass this input inside my sigmoid function and I will get a value as 0.96. Now, this value of this node will give an output of 0.96. Now let us move towards our output node. Now my output node is getting an input as 0.96 and my weight is W4 and my bias is B2. So in the output layer node, what will happen is also, because this is also a neuron, there will be two steps, pre-activation and activation. So during the pre-activation, I will multiply the input with the respective weights and add a bias term. So here, in this case, my input is 0.96, my weight is W4 and my bias is B2. So I will get my value of y dash, as y dash is my output of this particular neuron, to be 0.584. My input 0.96 gets multiplied to the weight 0.4 and I will add a bias term 0.2, which is pre-decided. You can see the question. So I will get an output as 0.584. Now this answer is of step 1 of pre-activation. Now I will move on to the step 2, that is activation function. I will pass this value inside a activation function. So inside the step 2, again I am using sigmoid. For the sake of simplicity, I will pass this input to my activation function and after solving, I will get a value as 0.64199. Now, I have received the output of this whole neural network as 0.641. From this step, from this part I got 0.96 and from this part I got the output as 0.641. 0.641. This is the output here. And you must be knowing that when I pass a data set, I had already specified that my actual output, the real output, the target variable is 1. So the correct answer was 1. And I'm getting an answer as 0.641 from my neural network. It means that there is a difference between my actual output and my predicted output. So now I will calculate my loss. So to calculate the loss, I'm using the simplest loss function, that is mean square error. Again, for neural networks, there are multiple loss functions that I'm going to discuss later on. But for the sake of simplicity, here I am discussing mean square error. So what I'm going to do is I'm going to subtract my actual from the predicted. I will take a whole square of that and I will divide it by 2. This is simply that we do in mean square error, and after that I'm getting output as 0.0648. Now my aim is to reduce this loss function. In order to reduce this loss function, now I'm going to be using the concept of backpropagation. And I will be using the concept of backpropagation again and again. I will train my neural network again. There will be backpropagation. I will train, and this whole and all of these steps get repeated until my predicted value matches the value of my target variable, or it comes closer to the target value or the actual value. So this is my whole forward propagation. Inside the forward propagation, I pass my inputs to our neural network. The input gets multiplied to the respective weights, and after getting multiplied with the respective weights, a bias term is added, and all of these steps happen during the step 1. And in the step 2, what I do is I pass the value obtained in the step 1 inside a activation function. So this happens in a step 2. This whole thing repeats for all the neurons inside my neural network till I get output from my neural network. And once I receive a output from a neural network, I will calculate the loss, and to reduce the loss I am going to use the concept of backpropagation. So forward propagation is passing the inputs and getting the output. Till here there is forward propagation, and after that there is backpropagation. That was everything you should be knowing about forward propagation. In the next video, we will be covering what is activation function. After that, we will be dealing with each and every activation function present in the world. So we will meet in the next video. Bye-bye.